This will be an introductory presentation to RAP as applied to broadcasting, and the particular demonstration is for digital television, and there are other videos in this series of broadcasting that also should be viewed, because this one on digital television will not give the complete picture, not even for that digital television. So please view the other ones also. I start RAP by clicking on the icon on the desktop. I log in as guest, which is convenient for this demonstration. It requires no password, and I have no need for access restrictions for this demonstration. This installation, my installation, was set up to start with an empty project window. It displays to the left the connected databases. I have one RAP database, that's my working database, both readable and writable. Then I have a number of archive type of databases, the FM TV database from ITU, FXM, LFMF, and also the Geneva 06 digital database of digital television and terrestrial audio broadcasting, digital audio broadcasting for Region 1. And there are a few others here. I can start another project which sets a map for me. This is a map in part of Sweden, and this particular part of Sweden is available in our demo version of RAP, so we usually make our demonstrations in this area. Much of the work in spectrum management and radio planning is geographically orientated, so it's good to have a good map viewer, good capabilities to present various types of maps and to perform manipulations in the map. The main thing I'm going to use it for is to navigate when I place new radio stations. The example for this video is digital television, and I will create a new digital TV station at some location. In the map, I place the cursor, I right click and select new station and TX position. That opens the template selector of RAP. All of these are predefined stations with all technical properties predefined. It's very easy to create new templates. The user of RAP can do that himself. And in this case, I'll use a template for a DVB T2 TV transmitter according to the high definition standard. So DVB T2, it opens like that. I will call this just DVB T2 station number 1. Now all data is predefined for this TV station. I can change data, of course, here by manual, for instance, double clicking in the frequency field here and enter some other frequency, 530 megahertz for instance, or I can select from an allotment a channel plan if I want to have this station instead on let's say 514 megahertz, channel 25. I can do that, and then I can remove the earlier frequency there. This is a practical procedure if I know that this new TV station is supposed to have exactly this frequency. If I later am going to use the automatic frequency assignment tool in RAP, I can do that, and then it will optimize the assignment in accordance with the interference conditions among all the existing and new stations that we are planning. For the time being, I'll just stay with 514 megahertz. On the TX equipment tab, there are more of technical information for this particular TV transmitter. So here I can see that the template is defined for a 30 dB watt radiated power, that's 1 kilowatt, antenna height 50 meters, horizontal polarization. The details of the parameters of the standard can be found as a transmitter property on the modulation tab, and in this case it is the 32K mode, selection of the DVB T2 standard, TG over TU 1/16, giving me a TG of 224 microseconds, and this in turn defines the maximum propagation difference, the distance, the maximum difference in propagation path distance, in order not to have interference within a single frequency network. So if transmitters are more than 67 kilometers apart in an SFN, there will be some interference contribution, because the guard band, time guard band of TG does not support longer than 67 kilometers. Whether that is harmful or not is another issue, and that can be analyzed in RAP by the coverage calculations. So we'll stay with this setting, and on the last tab there are settings in general to define, for instance, which TV standard, if I was using analog TV or any of the digital TV standards that we support. This of course has to be has to correspond to what we define for the transmitter. In this case it is a DVB T2 transmitter we're using, so we should use of course the same standard for the TV station. The effective antenna height can be calculated, and that is just by pressing calculate, and it is calculated for every 10 degree increment, 0 to 350 degrees, and this may be a requirement if the TV station is to be coordinated according to the ITU procedures. So there it is in the map now. I can open it again by double clicking on it, and it opens the same edit station there, and it also appears in the project list view here, where I also can edit by double clicking on it. The first quick demonstration of a calculation on this radio station, on this TV station, is with a coverage. I will do a field strength calculation, and there are many settings, many selections in the coverage tool, those that are relevant for broadcasting. TV broadcasting are mainly the field strength, the margin EW minus EU. This means wanted field strength minus usable field strength, and the margin in dB above that. So for instance, if a margin value of 0 is indicated, that means that we are just fulfilling the reception criteria in terms of wanted field strength and the nuisance field, which is the interfering field strength, and the protection ratio as a function of frequency offset. All the settings that I make in RAP can be saved and retrieved in order to personalize the appearance and the selection of functions, and parameters, and so on in RAP. I'm not using any kind of preset now, so every window opens in the preset, in the default mode for me. I select a mobile, and the mobile gives the technical characteristics of the test point where we move around over the calculation area where we are to determine the coverage. And I have plenty of mobiles here, and the selection of course would be much more limited if I had adapted my setup for broadcasting. I would select this one, TV DVB-T2 directional, because I want to make an illustration of using this planning for fixed reception. And I'll perform the calculation around the transmitter. I'll select a propagation model where we have many selections. I'll use the ITU P1546, which is popular for broadcasting. And I can make some settings here. For instance, we want to have a probability, the local availability probability of 90% to achieve coverage. When I press OK, the calculation starts, and there is a progress meter that indicates that now it is ready. The result appears in the results in project folder, coverage results area. We have other types, can calculate along lines or in points, in test points for instance. Showing this in the map gives this coverage. The irregular appearance here is due to the terrain influence, so it's due to hills and also forests and the buildings if there are, but this is mainly a rural area, so not much of building influence, but forest and hills influence a lot. I'll make some demonstrations of a map capability here where I can zoom in, and I can set the map to be displayed in grayscale, which is convenient when I have colored representation of the coverage areas. So I'll set the map to be displayed in grayscale instead of full color, which gives a clearer view of just the coverage. The values here, or the colors, represent the minimum acceptable field strength. Is automatically calculated based on the receiver properties. The receiver has, in this case, it actually has the nominal DVB-T2 properties, characteristics. In this case, it requires 20 dB signal to interference ratio. It requires it has a certain noise figure, and that calculates to a sensitivity, and with the use of the directional receiving antenna, it results in a need for 42.4 dB microvolt per meter field strength for good reception. By the way, I should inform here also that in coverage information, RAP supports population coverage analysis if a population database is available, and I could then perform a population coverage analysis, and the number of persons, people covered by these field strengths would appear here. Covered sum, for instance, that would be the number of households or whatever the population database represents. But not right now. There is no population database activated. The map has many display features. I can, for instance, change this to a three-dimensional display, which sometimes is nice when analyzing coverage in mountainous areas, and have a very clear view of what is producing coverage limitations, or the main obstacles, and that result in poor coverage. So 3 dimensionals can be nice sometimes, but perhaps we mostly use the 2-dimensional display for practical planning purposes. I'll return to the previous scale with a quick command like that, and I will remove the coverage because I'm happy with that. I won't show it, remove all results. Now for the further demonstration, I'll create a single frequency network in a very simple fashion and perform single frequency network coverage calculations. It is convenient then for me, when I create this default network, to show the stations with a circular area. So I will show the stations with a user-defined circular area, and I choose to do it with 40 kilometer radius. The reason for the 40 kilometers is that the particular settings of the parameters allowed a 67 kilometer maximum distance between two stations in order not to have interference contributions within the network. And with a 40 kilometer radius, placing other stations on the radius here will give a maximum distance of 80 kilometers, which is more than 67, so we should have some contribution of interference within the network. It's convenient now to use the quick copy paste command. So I press the control key, place the cursor on top of the station to be copied. I press and move to the desired location. When I release the mouse button, I create an exact copy. And I continue to do that now because to create this in a symmetrical way, it's just to place the stations at the intersection of the circles. That will give me the there it's behind the coordinate value there, but it is at that location, and we have one to place there also. So now we have 7 in a symmetrical network. I will create a single frequency network now of these. So I select the network and call it SFN-A, for instance, and give it a frequency. I forgot what, well, it's not important. Let's put it on 530 megahertz, or I could select again from the allotment, but that's okay to do in this way. And I define it to be a single frequency network, which is an important property, because then the interference calculations are changed to account for the dependence between the stations in the network. Now I put them into the network, mark them all here, enter them into the network, and press OK. That concludes. Didn't I put? No, I actually didn't. It didn't accept the frequency I entered. That was just a slight error on my behalf. So I'll select it from the channel plan instead. Select 506 megahertz. There we are, and now it should be okay. So I have created the network. It appears in networks in project, so there it is. Now to calculate the coverage for this network, the combined coverage of all the 7 stations, including the interference contributions due to the 80 kilometer maximum distance between the stations. I run the coverage tool again, but this time I mark all of them, and I select to make this as a combined calculation, a composite calculation. Signal to interference ratio, or carrier to interference ratio, it is the identical term. We tend to use signal to interference in RAP, but for all practical purposes it is the same definition as carrier to interference. Selecting the mobile again, and now I select an omnidirectional mobile, because I don't want to include the antenna discrimination that the directional antenna would give me to discriminate against interference. So with omnidirectional, it receives the wanted signal and the interference signals with the same gain. Well, 0 dBi in this case. I perform the calculation around the center station, and let's do it for 80 kilometer range, which includes then the 40 kilometer to the nearby station and another 40 kilometer to include coverage beyond that. I will not use a terrain dependent propagation model now, because of course I can do that, and in practice we would do that. But what I want to show now is the more symmetrical properties that are inherent in the single frequency network. And if I use a terrain dependent propagation model, that will be obscured by the terrain features, hills and forests. So this is a composite S over I for the SFN-A. The settings I've done now will give the median probability of coverage. I can make settings here to select other probabilities, but I'll just do it for the median. Pressing OK runs the calculation. and the result appears there. I make it visible, and it looks like this. The very nice symmetry due to the symmetrical nature of the network and non-terrain dependent propagation model, and not really harmful interference contribution within the network. Red color indicates better than 20 dB signal to interference ratio, and 20 dB is the defined requirement for this these settings of the DVB-T2 standard. Fixed reception, Ricean type of fading or location variability, and then the whatever requirements for the minimum the field strength and so on. Yellow is 6 dB higher, so 26 dB better than that, and green is 32 dB. These can be changed, and any values can be entered. The setting here for this particular calculation does not give a visible appearance of interference within the network, and the reason for that is that even though the maximum distance, propagation distance difference is 80 kilometers, and the standard allows for 67 parameters, at a distance where from a station where that propagation path difference would appear, that would be about 13 kilometers away from 80 minus 13 equals 67, so it's around here where I have the cursor now, 13 kilometers east of copy 4 of DVB-T2. At that point, the wanted signal from DVB-T2, the center station, and from the wanted the nearby station, and also from others here, are so much stronger than the interfering contribution, which only comes from a small part of the overlapping usable or in this case interfering signal from copy of DVB-T21. So there's no appearance here. If I were to have the distances larger, there may appear interference contributions and give a much more irregular behavior or appearance to this coverage. Now, this demonstration was only to display very basic and to show very basic capabilities in terms of digital TV planning. The complete analysis would also naturally include interference considerations to existing stations that can be found, for instance, in the plan here, Geneva 06, the digital TV plan. I would also then, in a complete demonstration of this, run the frequency assignment part of the broadcast tool, which is here, but that is a fairly similar type of presentation that will follow in a separate video where we talk about FM sound broadcasting, because the broadcast tool covers both digital TV, analog TV, digital sound broadcasting, and analog sound broadcasting. And this quick demonstration was actually just to give an overview of using the coverage tool and implementation of single frequency network calculations. So that concludes this presentation.